Rodney, and I will be your leader through this presentation today, switching from Mentor to Altium. It's easier than you think. We still have a few people trickling, but I'm going to go ahead and kick this thing off. It's a little bit past the top of the hour. This is slated for an hour session. I don't expect it to go that long, so let's go ahead and jump right into this. I've been with the company a number of years now. I have had the privilege of working with a local company here who's made the switch from Mentor, in this case PADS, to Altium, and I'm going to leverage off that experience. I personally have no experience with the Mentor tools. I don't have them loaded on my machine, so this will be a presentation from an Altium perspective. So having said that, I also wanted to let you know that this is not going to be death by PowerPoint. This is exactly the only PowerPoint slide you're going to see, so I'm expecting, as my audience is Mentor users, that you're going to want to be from that state, Missouri, where the tag name is Show Me. So this is going to be the Show Me state. I got a lot of presentation material, a lot of time spent inside of the tool. Let's go ahead and hop over and get into the tool at this point. And what you see here is Altium Designer. Now, I'll get into the user interface in a little bit, but what I want to do is kick this thing off and bring in a design from Mentor PADS. To do that, I go to File, Import Wizard, and I bring up my Import Wizard. Now, my Import Wizard allows me to bring in designs from various competitive tools. You have a list here. You can see Allegro in here, CADStar, Circuit Maker, DX Designer, Eagle is brand new as of Altium Designer 14, so that's got a good year behind it of translating designs in. Expedition, XDX Designer, the OrCAD formats, PADS, where I'm going to focus today. You can see that I bring in the .ascn txt files to make that translation, and that format, that procedure that a lot of people go through with OrCAD for the schematic and PADS for the layout, and then TCAD, of course, is a legacy Altium product that we can bring in. So the next thing I'm going to do is go ahead and go in here and click on that PAD and go ahead and accept that. At this point, I'm going to go navigate and go find those PADS files that I have out on my disk. I'm going to go in here and I'm going to go ahead and look at everything that I have in this directory, and I'm going to grab the schematic and the PCB. When I grab those, I'll drop those into this wizard. The next screen looks very familiar, or very similar, I should say. In this case, I'm not dropping any design files in, I'm dropping in libraries. In this case, I have no library, so I'm going to leave that blank. I'll move forward in the design, do some analysis of those files that I just brought in, and then I'm going to have the opportunity to go out and make some changes to my logging events. I'm going to leave that as a default. I also have the opportunity to go in here and change my PCB and PCB library import options. Again, I'm going to leave those at a default. And then I have the opportunity at this point to remap PADS layers into Altium layers. Again, happy with the way that works. I'm going to go ahead and hit Next. The end product that you'll see over here in my project panel is that I'm going to have a PCB document in its own project. I'm going to have a schematic document in its own project. Now, a project is an Altium concept. Altium does not rely on sending that list back and forth. It is a unified tool. I will get into the user interface once I've imported these. But it's important to know that when I bring these in the first time, they're going to be in different projects. And that's not optimal. That's the way the import wizard brings those in. And then I'm going to go ahead and hit Next here. Now I'm going to go out and I'm going to let the tool do its thing. In the background, you see I've created a PCB from that PADS file. In the foreground, you're going to see that, again, I'm going to go out there and I'm going to create that schematic. So just that quickly, I've taken the design, again, from the local guys here at Texas Instruments. They were kind enough to allow me to use their design for this particular demo. What you see here is two separate power supply designs in the same schematic as well as the same PCB. Let's talk about the user interface now that I'm here. On the left-hand side, I have that project panel. So I have a couple projects open that I'm going to use a little bit later once we get further into the Altium part.
Okay. Welcome to the webinar. You have entered as an attendee in listen-only mode.
All right. Don't know exactly what happened there, but I did find the mute all button. Thought everyone came in muted. So I'll go ahead and move on from there. This is the user interface. What you'll see is menus as you would expect in any Windows program. You'll see also shortcuts associated with that. What you'll notice as I open the different documents in here, and I'll be doing this throughout the process of this demo, I'll be opening PCB documents, I'll be opening PCB documents, I'll be opening schematics, I'll be opening libraries, both PCB and schematic, and maybe a couple other documents. And what you'll notice is I move from document to document. I move from editor to editor. I never leave this user interface. So when I'm in that schematic editor, I have schematic type things up here with their shortcuts. On my PCB, I have menus that are associated with PCBs, in this case 2D. I also have the capability to looking at this particular design in 3D. So there's your basic blank board that came over from the paths design that I got from my friends at Texas Instruments. Again, you'll note that these menu and shortcuts will change as I go from 2D to 3D with probably the easiest user interface ever, 2 for 2D and 3 for 3D. That's all I'm hitting is that key on my keyboard. I realize the data is the same. It's just different ways of showing that data. First thing I want to do is kind of clean this thing up. I talked about how the project is expecting to have a schematic and a PCB together. I can simply click, drag this, and drop this into the project at the top. The second project I no longer need, so I'm going to go ahead and close that up and move on to what I have here. Now, what I know at this point, having used the tool a bit, and you'll become familiar with, is that this little arrow tells me that this document is still in the directory from the translation that I did. What I want to do at this point is I want to save it in the same area as where my PCB doc is. So I'm going to do a save as. The save as, I'm going to go ahead and go up a level, go to this particular directory. Note that the schematic sheet is not there yet, and I'm going to go ahead and save it there. The feedback I get in the project panel is that little arrow goes away, and now I know everything exists inside the same project. So here's that schematic that I want to work on. The first thing I want to do when I get into the schematic is I want to go in here and I want to create a schematic library. So by clicking on this button, I go out and I find all of those symbols, and I get them into a schematic library. I bounce also into the schematic library editor at this point. Let me go back and look at my PCB. When I'm in my PCB, I'm going to do a similar thing. I'm going to go in there and hit design, and I'm going to make a PCB library. And now I've created a library of all those footprints that are on that board. I didn't have a library when I brought this thing over. Now I have a library that's associated with the project that I have in front of me. As you can see here, I have a PCB library and a schematic library. There's one other piece of housekeeping that needs to happen before I can move forward with this particular design. If I go into my schematic sheet, and let's go pick something nice and big and something recognizable. So I'm going to go ahead and go to this U2IC. If I click on this U2IC, the thing I'm going to see when this comes up is that I have a thing called a unique identifier. Unique identifier is how I identify something in the schematic as matched with something that's in the PCB. So let's go back to my PCB. I've got that particular U2 component already highlighted, and I'm going to go look at its properties. Now, the fortunate thing here is that I have not arbitrarily assigned a unique ID to this. And I say fortunate because if I did, I wouldn't know for sure that I was hooking these things up correctly, that U2 and the schematic really would match into U2 of the PCB. Luckily, I have a tool that's going to allow me to go ahead and make that connection. So under projects, I have a thing called component links. Under component links, these are all the things in the schematic that don't have a unique identifier that is matching in the PCB. We know that the PCB has all blank unique identifiers, and likewise, everything inside of the PCB at this moment does not match something in the schematic. And that's also reiterated here. There are no matched components between the two. Now, luckily, this tool allows me to go ahead and make that change quickly. I'm going to add pairs matched by designators, so those reference designators. I'm going to count on those being right, and when I do, that brings those all over. I'm going to perform an update. And now I'm okay. I have everything inside of this design synced up. I've taken the design in this first few minutes of the webinar and moved it from Mentor paths into Altium. Now what I want to do is take this a step further. I'm going to go into my PCB library, and I'm going to start making this a little more Altium specific. I want to leverage off of some of the things that Altium can do. And the first thing I want to do is to be able to use 3D bodies inside of this design. So what I'm going to do is I'm going to take a series of components in my PCB library here. I'm going to take these first handful. Maybe a little bit tedious on your end, but I think that the payoff is really big in what we get on the back end. So I'm going to take the first few. I'm going to go ahead and place the 3D body. In this case, I'm going to look for a generic step model, and I'm going to embed that step model into my design. For this first one, I'm going to go ahead and grab this capacitor model. I'm going to go ahead and take that, make some adjustments, and go ahead and drop that down. At this point, I've got a 3D body of a capacitor, and I'll drop that in. I'll try to go through these as quickly as I can. Again, a bit of librarian work, but I wanted to do it live in front of you so that you can see that in terms of a webinar, it is a bit of extra time, but in terms of actually creating a library, this isn't a lot of time, I believe, for the ability to bring in the functionality that I'm about to show you. So I've got 2 of those done. I've got a handful more to go. If you'll bear with me, I'm going to go ahead and you'll get used to me doing place 3D body, go out and find that 3D body. In this case, I'm working on an inductor that has a particular footprint and a particular orientation. So the thing you're seeing me do here is I'm actually fixing the orientation, because when I brought these in from the various sources that I got them from, and the various sources that I got them from are from the manufacturer or from a website called 3dcontentcentral.com. Now this particular one is hiding down here, so I'm going to have to go up and grab him and drop him down. So all very good sources for bringing in 3D content. Again, bear with me as I go through this process of adding the 3D models to this particular design. Just a couple more here to go. One more after this one. Drop that guy in. Again, this is something that you would do exactly once as a librarian and bring these in. Since they're in the library, you'll be able to bring those in and always have those associated with these particular footprints. So quite a bit easier behind the scenes work that I'm doing. But again, I captured this thing live. I didn't really have an opportunity to go ahead and pre-bake these, make these things look the way I wanted to ahead of time. And I seriously thought that it would be a lot better to show you live what happens when we bring in these 3D bodies. Now that's the last one that I want to bring in. Let me go ahead and drop that guy down. And what we're going to do real quick is I'm going to go back into these parts that I've just added. I'm going to go into that 3D mode. Recall that I'm hitting the 3 key on my keyboard, and you see that I have added these 3D bodies to these footprints. If I go through here, those are all the 3D bodies that I just did in a matter of probably a few minutes. So I think very much worth the time that I spent doing that, at least from a librarian's point of view. Let's go back and take a look at this particular design. Let's go ahead and look at it in 3D. And I still have that blank board there. So I haven't taken advantage of the work that I've done, but I'll go back to that PCB library editor and go in and say, okay, let's go ahead and update this PCB on all layers. I'm going to go out, the tool's going to churn a little bit, and then we're going to go see the payday for the work that I put into doing this. So again, now I can go ahead and look at this, and you can see all those 3D components that I added just in a few minutes there. So I've taken a design that lived in the Mentor world up until about 10 or 15 minutes ago, and now it lives inside of Altium, has the ability to see what those packages are like. If you wanted to put this inside of an enclosure, you would have those true heights. You have that photorealistic view of this. Actually, my friends at Texas Instruments showed a manager one of these boards once, and they said, oh, you've got your boards back. That's pretty cool. And they said, no, this is just a picture. This is a 3D rendition of what my board would look like. So I've done some playing inside the PCB library. Let's go inside the schematic library. If I go inside the schematic library editor, and remember, again, I have not left this user interface. I am transferring information back and forth inside of memory. You'll never see a netlist made when I'm doing the work inside of Altium. I'm going to go ahead and double click on this guy and see the parametric information. Now this parametric information is parametric information that I got when I did that transfer from Mentor pads to Altium Designer. I extracted that library and I still have this information in there. And that's a good bit of information in there. But what I'd like to do is probably make that a little bit better. Windows program, Control-C, I'm going to grab that, and I'm going to go to a thing called my supplier search. Now supplier search allows me to drop this particular value back in there. I can also look at various suppliers that are well known in the industry, the DigiKey, the Farnells, the Arrows. In other words, the Mausers of the world. I have the capability to come in here and put in my user ID and password in case I have negotiated pricing that will come across. I can rearrange these by using the move up and down buttons. I can also enable or disable suppliers that I would not use. So this is a list of those things. What is going on here is I am pointing to their website. I have access to the back end of their website, and I am pulling in real-time parametric information, which is static, and also pricing and availability information, which is dynamic, which is to say it's live data. Now, I've already done this once today, but I'm going to go ahead and hit the search key and let this go ahead and do what it needs to do again. I'm going to pick any part. In this case, I'll pick the DigiKey part. I can look down here in my bottom pane and see that I have a bunch of information. I have a bunch of parametric information. I have pricing and availability information. I even have a link to the data sheet for that. I want to get that information into my schematic library. I want to do it once. I want my librarian to do it, and I want this available to me whenever I go forward to create a design. If I do that, I can right-click here and simply click on Add Supplier Link and Parameters to that part. When I do that, one of the things you'll notice over here on my schematic library editor pane is you'll see some of that information showing up down here in the supplier area. And if I go in and double-click on this, as I would if it were a part on my board, you see that I have a lot more information in here. I have, for instance, operating temperatures. I have pricing. A lot of information that I can find useful in making a bill of materials or just making design decisions about this particular part. So I brought this part in. I've extracted a library. I've added 3D footprints to that part. I've played inside the schematic editor and added some parametric information. One of the other neat things that, about Altium Designer, once you get into the tool, you'll learn is that we have an extensible, we have an open architecture. There's an SDK associated with this tool, and we've invited outside vendors to come in and make enhancements to the tool. One of the enhancements that you'll see is if I select this particular device, I have the ability to go out and do an Octopart lookup. Now, Octopart is yet another company. I showed you those 12 suppliers. This is above and beyond that. These guys can see into 200 distributors worldwide. If there's some oddball part that my suppliers that I had picked earlier don't have, this is a good place for me to go look for them. I have wild-carded this automatically, so I see all the different variants of this particular part. And if I click See Part Details, at this point I'm going to go out and get that information via Octopart, via this open extension into Altium, all the places that this is available. Some of them we know, DigiKey, Newark, Mauser, some we don't. Avnet Aero Express, Chip 1 Express. So yet another way to look at that data to get more information into your design. So now we're well into Altium with this particular design. What I'm going to do is I'm going to go ahead and do a compile. I'm going to go build the database behind this because I want to do something kind of interesting. I'm going to go ahead and grab my schematic sheet. I'm going to rearrange my tabs up here. And there you can see my 3D of my PCB. I'm going to go in and split the screen. Since I don't have the luxury at this point of showing you two monitors, I certainly have multi-monitor support. So I've got my schematic on top, my PCB on the bottom. If I go into my Design Compiler tab, I have a thing called a Navigator. And what the Navigator is going to let me do is go in here and look at the components that I have in this particular design. So if I want to go find out where these components are, do a cross probe, if you will, I'll go in here and let's go find C7. If I find C7, there it is on the board in 3D. There it is on my schematics. Likewise, C13, let's just go grab something that's probably a little more interesting, those big old inductors that are on there. There they are in the schematic in the PCB, and probably the most interesting thing on here are the ICs that are used to drive this particular design. So let me go ahead and put that back together. Basically, the point of that was to show that I have taken this design that was a MentorPad design and is 100% compatible with all the things that I want to do inside of Altium Designer. Now, on the side of Altium Designer, and as we know, I have a power supply design here. I've got two different supplies on here, And kind of reminds me of the days when it was 5 volts only. Those 5 volt only designs are gone. As a matter of fact, they've been replaced with multi-supply designs. And also wanted to bring the point, a part of Altium Designer, which is called the Vault. And I'm going to try to be careful here. I have a thing called the Altium Content Vault. Now, this is free with your subscription. What it is 350,000 plus components that have been created by dozens and dozens of engineers behind the scenes at Altium. This is growing daily. What I decided to do with this particular thing, and it is, again, free with your subscription. So you get subscription, you get this. You get support within the United States. For those early risers on the East Coast, we have people in Boston. Those people that stay up late, we got people in Carlsbad, California. And for those people in the Central Time Zone, we get the benefit of both of those coastal locations for Altium Designer. I went in here and you can see inside of this Altium Content Vault kind of the who's who of the industry. Certainly TI's in here, former National Semiconductors in here. And I picked out Altera because I'm a little bit prejudiced to companies that have A as the first letter in their name. Now the reason I picked out an FPGA is twofold. One is some of these parts can get quite gnarly. What I mean by that is I got a package here that's got 760 leads in it. So what I've done for you is I've gone in here and I've created that footprint for you, that 1760 pin component with all its pads on there. I put a 3D body to it. I have a schematic symbol that goes with that. So I've done a lot of work here. I'm going to probably be a little generous here and say if I'm going to go ahead and use these Altium Vaults, which I'm allowed to, it's free with subscription, you can see I have 29 pieces of schematic, huge device. I don't want one big box to dominate a schematic page. If I go out and use this, I've saved myself, let's call it a week on a 1760 pin package, knowing that I've got the schematic and the footprint done for me ahead of time. Now let's take another peek while we're in here. Down at the bottom here, I have generic components. And I'll talk to these resistors. I've gone out and created all those standard resistors that you're going to use in your design. And you pick them up from inside of Altium and drop those onto your design. So let's go back to my schematic and talk a little bit about libraries and about how the vaults play with the libraries. Now I do have a library panel in here, and I've gone out and I've made a link to those resistors I showed you. It's about 8,000 of those in there. And you're saying, Rodney, that's great. You got 8,000 resistors for me. How am I going to find the resistor that I want to use? So it's quite simple, actually. I've got some parametric information up here. I have a choice of what I put up here as a column. I'm going to go ahead and say, well, the most important thing to me is that I want to find a resistor of a certain value with a certain tolerance in a certain package. I've gone in here and I've sorted these things down hierarchically according to that. Now I merely go into a particular value of resistance. I find a tolerance. I go pick the case, and there is exactly that one part that I need to go drop on my schematic. So very, very handy, very, very good way. You get your arms around all that information that we supply for you inside of that Altium Content Vault. Now we're talking about FPGAs. Now FPGAs are a bit of a monster, and I picked them on purpose because those things are hard. If I drop down an AND gate or an AND gate, or even the stuff that you see in this relatively simple design, you won't get a feel for some of the time-saving features built into Altium. Now, one of the things we've done, and again, we're partnering with pretty tight partners with Texas Instruments, you'll notice that I have a WebBench extension inside of Altium Designer. What that allows me to do is hit all those pieces of the WebBench architecture. If you're familiar with this, it's going to help me make power supplies. In this case, a single rail. In this case, multiple rails. In this case, for that FPGA that I just picked. Now, there's a series of streams, and it does take a bit of time, and I did make you sit through watching me put those 3D bodies onto those footprints. So I'm not going to make you do that. I'm going to go ahead and fast forward in time. I'm going to go to this WebBench screen for the particular FPGA that I've chosen for the Altera part. See the IC name of the IC that I'm going to use for this. And what I have is a series of power supply outputs. Power supplies, there's different rails for different pieces. They need to come up in different orders. Coming from a silicon world, I've seen what latch-up can do. You do not want to bring those power supplies up in the wrong order. If you do, you destroy that part, and you paid a lot of money for that part. Inside of WebBench, I have the capability of going in and making this footprint smaller, lowering the BOM cost, but lowering the efficiency, or clicking over here and have the highest efficiency part, but maybe having a bigger footprint and a larger BOM cost associated with that. And the last little bit about web branch extension. The reason I bring it up is I can do an electrical simulation on these power supplies. I can do a thermal simulation on these power supplies, and probably most importantly, I can download that into a CAD package. I can download that into Altium Designer, so I have the schematic native and ready to go. I also have a PCB layout that I can use in that case. Now let's go back to my original design. Let's go back to an Altium topic, because I pretty much brought this thing in and made it functional inside of Altium. Now I want to leverage off some of the things that Altium allows me to do. One of the big things that we allow you to do, and probably the big differentiator in my mind, is data management. Data management, we're going to take care of your data. All of us guys do a good job of laying out circuit boards and PC and schematics. So there, maybe you like the features of one guy better, maybe you can do a little bit faster, maybe you have those shortcuts under your fingers so that you can move a little bit faster inside of the design. What I want to tell you is, yeah, if somebody saves you a little bit of time and they let you send out the wrong PCB to be manufactured, no time was saved, months were lost. So that's why we make a big push about data management. And I like to talk about data management at 3 different levels. Version control, that day-to-day, hour-to-hour, that chaos where you're being creative, where you put down a bunch of capacitors. You don't know how many you need, you don't know how many what the value is going to be. And over time, you're going to iterate down that, ratchet that down, and get the right answer. So as you put those things in, you're going to have the patience to go put that in version control and leverage off of that. The next level is what I call the PCB release. Am I sending high integrity data to my outside vendors so they can build the perfect design I have that I've created? Because for them to create the perfect design, they have to have perfect data, and we have a process that allows you to do that. And at the pinnacle of the data management is a separate product from Altium. It's called the Altium Vault. You saw the Altium Content Vault. That's an example of how we use the Altium Vault to do the library portion of the Altium Vault system. At this point in time, I'm not going to dive into the vaults. What I want to do is I want to make a very clear distinction in this webinar that everything I'm showing you comes with plain Jane Altium Designer. You do not have to pay extra for anything that I'm going to show you today, and that's why I'm skirting the topic of the vault. Vaults will certainly be a topic for a future webinar and could probably fill an hour on their own. So let's go talk about version control. We went out and we talked to the other disciplines, the mechanical guys, the software guys, the firmware guys. What makes you guys so successful and so efficient? And they said version control, and we came back with, well, would you ever consider doing design without it? And they said we'd be crazy. We'd be crazy for no other reason than it's built into our user interface. So that was kind of an aha moment, a eureka, a light bulb moment for Altium, because what we did is we went out. We went to our data management and we put version control in there. We have a built-in version control. It's Subversion. It's open source. The only thing the user needs to do, comes in automatically, is point to a design repository. So you can see I have a couple here. One of those resides on my hard disk here. What I want to do with this design that I brought over this morning was a mentor-only design. I want to go ahead and bring that guy into Altium Designer and use it in Vault. Now that it's in Altium Designer, use it in the Vault. So the first thing I'm going to want to do is go ahead and save some of this stuff. I need to save my project. I need to save my PCB. My schematic hasn't been touched. I'm going to just go ahead and save my libraries. Now everything's up to date. And you'll get used to this sequence of I'm going to go out and save things, and I'm going to go put those in version control. So you notice here my project changed because I changed a link inside of the design by saving that schematic library at the end. I'm going to go in here and I'm going to click on this. I'm going to go right-click, do version control, and add this project to the version control. I'm going to go ahead and add a new folder. Don't really like that name. I'm going to go ahead and shorten that so it's a little more apparent what I got going on here. And probably hide a little bit that this actually came from another tool. So I'm going to go ahead and click on that and say OK. At this point, it's going to go out and scan the files that I have out there. I'm going to grab an extra one and say OK. So at this point, I'm going to go ahead and start putting this particular design into version control. Another right-click in here to version control will allow me to commit that whole project. I like to put a comment in there so that this is the initial commit. So now I've taken all of the aspects of the design, these individual documents, and I put them into an SVN version control repository. Now let's go have some fun with this. Let's go ahead and open up the PCB document again. I'm going to go slip back into 2D. Recall once again that you go from 2D to 3D. I'm hitting the 2 key on the keyboard and the 3 key on the keyboard. I'm going to go ahead and clear out my mask here and zoom out and go ahead and take a look here. Now what I want to do at this point is I want to play around with. So I'm going to change this because version control people are used to in that mechanical and that software world where it's not very complicated data. You can imagine inside of a PCB, this is very complicated graphical data. What I'm going to do is I'm going to go in here and do a series of keyboard shortcuts. I'm going to go ahead and grab this particular test point, grab that test point, drag him, take that trace with him. And let's go ahead and just drop him next to test point 10. Now the thing you're going to notice here, and this is something we'll notice later, you remember that it was closer down here and now it's further up here. We're going to notice at this point that my file folder says I am modified. First thing I want to do is go in there and save that. As soon as I do that, my version control, the head of my version control does not match what I have in my current editor. So I'm going to go ahead and go into my version control one more time, and I'm just going to commit that document. And I'm going to say move test point. Not a very good comment, but gets the point across. Now I've gone ahead and done that. What do I do with that information? Now, luckily, I have a thing called the storage manager. The storage manager is going to let me go in there and look and see what I've done with this particular design and potentially go find things like this. What I'm going to do is I'm going to go in and I'm going to click on that move test point. You know the comment that I just put in there in my initial commit. Now the thing I can do is go in here and I can compare these two. So what's going to happen is I'm virtually going to hold those two things up to the light like we used to do in the good old days and see what changed between those two particular designs. Go ahead and grab this, grab the storage. Well, what you'll see in here is that this component test point has changed, also the net associated with it. So I'm going to go ahead and click on the component test point in one area and then on the other area. So I've got in here that test point. I've shown in here that I have it moved away from the pad in one place, moved away from its original position in one place and in place where it was originally in the other. So very valuable. You can imagine changing things in your PCB and being able just that quickly to find the differences between the two. So that's a look into version control, a useful way to use version control. Let me go ahead and clean up my screen here before we move on to the next thing, which is my ability to send this stuff to my outside vendors. Now this comes in two pieces. The first piece I'm going to talk about is I'm going to go in and I am going to create a new document in here. I'm going to add new to the project a thing called an outjob file. Now an outjob file is a series of containers, either the PDF folder structure, PDF for your documentation, folder structure for your outside world. Actually, I can also do videos as part of documentation, and I'll go ahead and get into that in the last piece about what I'm going to talk about today. So everything on the left-hand side is something that Altium Designer could create. The who's who of netlist out there, documentation, I can do 3D prints, I can do schematic prints, I can come in here and do my pick and place my assembly drawings, my test point reports, all this fabrication information. I'm going to go ahead and focus on that in a second. Here's some reports that can come from within inside Altium, not the least of which is your bill of materials. Validation output jobs are very important as well. In here, I have the ability to go in and rerun that design rule check to make sure the thing I'm sending out at that moment is exactly correct. A difference report. Is there a difference between what I've implemented on the PCB and what I have in the schematic? Electrical rule check, a compile. I'm going to go out there and make sure I don't have floating inputs, I don't have two outputs tied together, and much, much more. And then a footprint comparison, because we know, engineers, we need to get our jobs done, but we don't need to go out and take a library footprint element and change it for our own needs, because we've changed something probably from something that's been validated in a previous design. And using this validation check, I'm going to flag those and prevent output jobs from happening. Let's go into those fabrication outputs. I'm going to go in here and I'm going to grab this Gerber, and I'm going to grab the NC drill, because those guys usually go together. As a matter of fact, they should always go together. Let me go in here and I'm going to grab my ODB Plus, another file format that I'm sure you're all familiar with. But the one thing, and the reason I picked on the fabrication outputs in this case, is that I have this Gerber X2. Gerber X2 is a new format. It's an extension to Gerber, and what it does is it allows you to use that familiar Gerber look and feel, but it extends it so that everything you need to build that part will be in one place all together. So the net list, the stack up information, the stuff you didn't have before. And then the last thing I'm going to bring in here is this IPC 2581. Now, these are both new file formats. They've been added to Altium Designer. I'm going to go ahead and put those in a folder structure, and they're going to go out into the folder structure in this particular order. Now, at this point, I can go out and generate outputs. What I want to do is talk about publishing this, because we don't want you to send emails to your vendors to the outside world, because that duplicates the data. There's confusion. Which one am I supposed to be building? It could be the one that got caught in the spam filters, that the file sizes were too big, or that somebody just deleted on the way in. What we want you to do is publish it to places like Amazon S3, Box.com, or FTP. If there's any question as to which design you want them to build, they need to go look in there. If that's the thing they're building, that is unambiguously what you want them to build. I've talked about this outjob file. What I want to do with this is take this to the next level of abstraction. I want to take this to what we call our PCB release view. Inside the PCB release view, this is a process where I'm going to go and make sure that you're sending high integrity data to the outside world. Ultimately, I'm going to want to put you into that Altium vault, not that content vault that's free with your subscription, but an Altium vault where you can create your own libraries, you can create your own repositories for putting your designs. The way this works is I'm going to go in here and I'm going to create a snapshot. It's an atomic process. I'm going to kick one button off. As I pass through these 4 different steps, I have to be error-free in a previous step to go to the next one. There's little gates in here to prevent you from moving forward, and this generate outputs is where your Gerbers actually happen. So when I go out to check out that snapshot, first thing I'm going to do is I'm going to look and see, hey, I've got something modified in here. Do I really want to release this design? Probably not. I want to save everything. I want to get it up to date in version control. The next thing I'm going to do is I'm going to look and see, do I have all green check marks? If not, I'm going to stop right here. Now, assuming I'm all good as far as things saved away and everything's current in version control, I'm in a very stable state, I'm going to go take that snapshot and grab it and run my validation test. So I'm going to go back and look and see if any of those footprints got modified. I'm going to run my ERCs and DRCs, and I'm going to want 0 errors. I can't get to the Gerbers unless there's 0 errors. Now, while you're out there making your schematics and PCBs, we're behind the scenes making a relational database, and we have a query language, so you have the granularity to write a rule to the pin on a part to make sure that you pass that. And that's a very good documentation, shows what your design intent was. A lot better than, yeah, that's an error, I know what it is, let's ignore it and move forward. You can't with this particular release mechanism. Now, you can certainly go around this. I recommend you do this. People are doing more things with less people and less time. Let's get it right the first time and move on to something else. Then finally, I generate those outputs via the out jobs that I showed you in the previous example, and then I send those to the outside world. Ideally, I commit those to an Altium vault. So we're about 40 minutes into the presentation here. I did want to take a brief detour and talk about something that we do. Again, that is unique. Something new, relatively new to the industry, certainly new to the ECAD space, and that is the ability to do rigid flex design. So the first place I want to go with rigid flex is going to my layer stack manager. Inside my layer stack manager, let's simplify this. If you're just doing a fiberglass and copper board, this is the area you're going to use. This is an example of a 4-layer board. I have the ability to save and load these so I can have a library of these things. If I want to go in and go ahead and make a rigid flex, I can set up those stack ups. Here's my rigid stack up, which is all 4 layers. Here's my flex stack up, which is only those outside layers as defined by these check marks here. You also notice that there's a flex keyword that's been checked here because flex can do something that rigid can't. Let's go ahead. I've made those changes to my layer stack manager, and now I have the capability of going in here. Let's go look at this thing in 3D. The first thing you're going to notice in here is that this thing does line up exactly the way we expect it to. So I've got this flexible region out here, the arms of the snowman, if you will, and that's the flex region. I have the full stack up on the rigid region on either side. You'll also notice that I have components on this flex region. If you were careful before, you'd know that this is the bottom layer. That's mid-layer 3. I'm putting components on a mid-layer. Now that is becoming reality today, and as a part of doing the rigid flex and being able to put things on these internal layers, I enable that in the general sense, in the rigid sense. My friends at Texas Instruments have a package called PicoStar. PicoStar is in a wafer scale package that is intended to be put in the internal layers of a board. You get a small footprint, a high power density in some of their power modules. Now we started out putting components on one side of a board. We put them on the back side of the board. The only place left is to go ahead and put those in the center of the board. And with the current edition of Altium Designer, you're able to do those kinds of things. So let's go ahead and look at this thing just a little bit closer. I'm going to open up a panel that talks to my PCB. What I'm going to do is go in here, and show you that I have 3 different regions. And in the region that's flex, this one in the center here, I have a sequence that's associated with angles and radiuses. So what's going on here is I literally can go ahead and take this design and make it not flat. Go ahead and fold that up, stop at any point that I want, and make that fold up. So now that I have this design, I basically have a hockey puck looking thing here. I also have the keyboard shortcut that's going to allow me to do that pretty quickly back and forth. Let me go ahead and open that thing back up one last time. Let's flip that over and see just how thorough this particular way of working with the rigid flex is. Let's go ahead and pick a device on here. I'm going to go ahead and double click on this particular device, the X3 device, and I'm going to move it from the top layer to the bottom layer. So magically now it's on the back side of the board. If you look at this board, you can kind of see when I go to fold this thing up, this is going to interfere with that battery clip. So not something that you want to happen, but if it is something that does happen, you want to know about it. So when I close this thing up, the internals of this turns this green color. That is my DRC violation color, and it tells me that I have a collision. Go ahead and open that guy back up. Go ahead and move that to a region that I know is safe. Let's go grab that X3, grab him, pick him out on this edge here, and let's go ahead and close that thing back up. You'll see the green color doesn't happen, and if I navigate well enough with my 3D mouse, you'll see a lot of black silk screen around that thing. So you can see, yes, absolutely, that particular device is clear once I folded that thing up. The important thing to note at this point is that rigid flex happens in a lot of places. It can happen in aerospace where those mechanical connections, that's the problem. We've got to make sure those mechanical connections work. We don't want to have that field service strip to that satellite orbiting the Earth. Or maybe you have you're that lucky guy that's making all those handsets in the cell phone world. A 1% fallout in the cell phone world because of a mechanical connection is a huge number of parts. Now let's talk about that cell phone. It probably has 3, 4, or 5 of these particular flex boards, and they're all connected with the flex material in between. How do I tell somebody in a different part of the world how I want to put that together? Well, let's go back to that PCB movie editor that I spoke a bit about earlier. I'll go ahead and grab that and bring this over to the screen over here. I have, let's see, where did that go? PCB, 3D movie editor. So I have a movie set up for this. Instead of, I'd rather use a picture than 1,000 words. So let me go ahead and show you what could happen if you needed to document that, maybe in a different language. You just send them a video. This is how I want this to fold. I want it to fold up. I want the arms to come around and the top to come across the top. Again, if you'll recall in my discussion about out jobs, this is something that comes in that documentation package that you can give to your outside vendors. Now I've got one little more piece to do, and then we'll go ahead and wrap it up for today. I've got a design open on my other screen here, and I'm going to go ahead and bring that on. Because as I mentioned earlier, we definitely have multi-monitor support. What I have here is just another view of a rigid flex design. So let's take this as an opportunity to go back and review the things that we've talked about today. I've taken a design from Mentor pads. I've made it Altium. I've gone in there, I've fixed those unique identifiers. I've played inside the PCB and schematic libraries. I've gone ahead and added 3D models. I've added information from suppliers. I've shown the Octopart interface. I've shown that I can cross-probe, that it truly is integrated into Altium. We talked about the content vault. We talked about WebMesh. We talked about those big FPGAs and how to power them and sequence the power. We talked about version control. We talked about out jobs and the PCB release. We've just finished up talking about the rigid flex, which is an award-winning part of the tool. We got an award there last year at DesignCon associated with this. And as I'm twirling this thing in space and kind of gazing at it, it kind of reminds me of a dice and gambling, know when to gamble, when to take the sure bet. So when I go ahead and think about migrating from another tool into Altium and all the benefits that come with it, and basically how easy it is to do something like that, I want to leave you with just this. Switch from Mentor to Altium is easier than you think. And there's the number if you want to have a conversation with an FAE such as myself or someone in the sales organization. I hope you found today's webinar interesting. I hope you found it compelling. I hope it makes you think about the way you're doing things today and the way you may want to do things coming into the future. That concludes this webinar. Good day.